Okay, so today we're talking about, this is homework 18, and we're talking about exponential functions. Now our x, our missing variable, is going to be in our exponent, okay? Let's clear this up for you guys. Hope it'll get a little bit better, not as grainy. Okay, I'm doing this from school, so I hope it's probably not as good as when I'm doing it from home. Anyway, basic exponential functions have the following properties. The domain is all real numbers, and the range is from 0 to infinity, which we'll get to down here. It also has a horizontal asymptote at y equals 0. There are no x-intercepts, and c as the y-intercept initial amount. Okay, so now we're going to graph functions like this. 3 to the x power. So I know most of us are going to pick our positive numbers, but let's start with 0. And let's pick 1, 2, and 3. And let's go ahead and go to 4. All right, so we're going to say 3 to the 0 power. Anything to the 0 power is 1. So this is the point 0, 1. Then we have 3 to the first power, which is 3. This is the point 1, 3. Then we're going to plug in 2 for our exponent, and we get 9. So it's 2, 9. 3 as our exponent. 3 to the third power is 27. So it's 3, 27. And then 3 to the fourth power is 81. Do you see how our y values are getting really big, really fast? Okay. Now, let's go to our negative exponents. Well, when we go 3 to the negative first, we can't have a negative exponent, so you put a 1 over it, and it becomes 3 to the first power, which is just 3. So we have negative 1, 1/3, and then negative 2 would be 3 to the negative 2 power, which is 9. So it's going to be 1 over 3 to the second power, which is 1 over 9. So we have negative 2 and 1/9. Now, because I did the 4, I didn't have room to do the negative 3, but let's go ahead and do the negative 3. So we have negative 3 to the third power. Okay, so that is going to be 1 over 3 to the third power, which gives us 27. Okay, what you will notice, let's graph the right-hand side. So we have 0, 1. And I'm sorry, but they counted by 3 so they could get that 327 in there. So 0, 1's about right here. 1, 3 is our next point. 1 of 3. Then it was 2, 9. And then it was 3, 27. And guys, if we had graphed 4, it would have been way up here because it was up at 81. Then negative 1, 1/3 is going to be really close to the 0, and then you get it closer to 0 because you have 1/9, then 127. This is going to get closer and closer to 0, but it's never going to touch 0. So an exponential function comes in like this. Oops, I kind of went up. It never touches the x-axis because remember, there's no x-intercepts, and there's a horizontal asymptote at y equals 0. Okay, so let's take a look at this one right here. Again, let's do 0, 1, 2, and 3. I usually start with 3, 2, 1, and then go to my negatives, but that's okay. You're going to have 2 to the negative 0 power. Again, that is anything to the 0 power is 1, and then that's 0, 1. Then we have 2 to the first. When you plug in 1 in for x, it becomes a negative 1. Well, that becomes 1 over 2. Oops, that would be 1, 1/2. Try to get this right. There we go. Then when we plug in 2 into here, that becomes a negative 2. So that's going to be 1 over 2 to the second, which is 1/4. And then when we plug in a 3, the 3 becomes a negative 3. So you have 1 over 2 to the third, which is 1/8. This is 2, 1, 4, 3, 1, 8. Okay, now, so if we graph these, let's just graph those, okay? We have 0, 1 right here in the middle because we're counting by twos now. 1, 1/2, 2, 1, 4, 3, 1, 8. Again, it's getting closer and closer to that x-axis there, but it will never touch it. Because again, we have an asymptote that comes through here at y equals 0, which is the x-axis. Okay, so it's going to come down like this, really close. And then let's go to -1, -2, and -3. So now I'm going to have, hold on, let me move this down. When I plug in a -1, it is like saying 2 to the -1. So that makes it a +1. So that's going to give me 2. So that is -1, 2. Then when I plug in a -2, that's going to give me a +2, which gives me 4. And then same thing with the 3, it becomes a +3, and that's going to give me 8. So this is 1, -2, 4. And this is -3, 8. Okay, let's graph those points. -1 up 2 right here. -2 up 4 right here. And -3 up 8. And then if you did -4, that would be 2 to the 4th power, which is 16. So see how it goes up very quickly, rapidly, because 16 would be somewhere right in here. And it comes in like this. What I want you to notice on both of these, even though the graphs are different and the scale is different, it always crosses at 0, 1. There and here. Okay, until you start moving these things up and down, or right and left, at this point, if it's just a straight up exponential function, it will always have that y-intercept of 0, 1, always. Okay, this is what we consider an exponential growth. This is what we consider an exponential decay. All right. Now evaluate exponential functions with base E. You'll learn more of this when you, for those of you that are going to move on to calculus. E is a universal constant, like the number pi. We know pi is 3.14, but in reality, it never stops. It's an irrational number, okay? See how our calculator will only hold so many numbers. Well, E is the same thing. It's just a 2.71. So you can find E somewhere, well, I mean about that. You can find E 2 different places. Right here, above your division sign. That is just if you had E. So let's just show it to you. When I hit that, see how I get 2.72, it should be 8, and it's an irrational number. It's like pi, it's just a different number, okay? The other place, okay, so that one I got to above the division. I hit my blue button or yellow button to get to it. The other one is if you had e to some exponent, you can use this. Now you can use this one with your caret key to raise it to a power, or you can just hit this one. Either way, when I do second and I hit that, then it gives me a place for my exponent. So in this case, it's going to be 2. So seeing I'm already here at this, I'm just going, well, actually, let me make it a 1 and you'll see how it gives me the same thing. Okay, now here, it doesn't matter which E you use, just raise it to the second power. And it says our directions say to round to 4 decimal places, okay? So this is going to be approximately 7.3891. Okay, now we're going to do the next one. So we are going to send, I'm going to switch pens. 45 e to the negative 0.23. And we get this number right here. 35.750. Oops, I missed one. 40. The rule of thumb is if it asks for 4 decimal places, unless it rounds to a whole number, or if it is a whole number. Well, actually, if you're having to round to 4 decimal places, you want something in that 4th decimal place. Okay, and this one right here, we're going to raise that to the square root of 7. And we get this number right here, 14.0940. Okay. Now, exponential functions to compute compound interest. All right, you've got to learn both of these formulas, okay? So here's what we're going to do. Actually, I'll have to look this up whether we give this to you or not. I'm not really sure. Suppose that P dollars is invested or borrowed. That's what I consider the big chunk of money that you're going to put into a savings account or that you need to borrow. Okay, that's a big chunk of money. At an annual interest rate for T years. Okay, that's our percentage as a decimal. Always. And T is our time, and it's always in years. Always. Okay. So they give you these 2 formulas. They give you this one, and they give you this one. And you have to decide on which one to use. So that's if I will give you the formulas, I will not tell you which one to use. I will just give you both of them. But the key thing you want to look for is continuous compounding. If it's continuous compounding, you always use this one. This one here is going to say in compounding periods, okay? And what that means is they might say weekly, okay? If it's weekly, there's 52 weeks in a year, okay? So let's do if it's weekly. Okay, let's say. So it's how many of those are in a year, because it's always the compounding periods per year. So if it was monthly, there are 12 months in a year, so you'd use n equals 12. All right, so let's try some problems. First of all, compounded annually, compounded quarterly, compounded monthly. You have not seen the word continuous. So in that case, we're always going to use this formula right here. The A equals my principal times 1 plus my rate over n raised to the nt. Okay, so it's our big chunk of money is our P. So suppose that $15,000, that is going to be my P. Is invested with 2.5% interest. This is my R. My R, I have to move it 2 places to the left. Okay, that's how you write a percent as a decimal. That's the shortcut. Or you can say 2.5 divided by 100 because that's the highest percent you can get, and it gives you that 0.025. So that is so we have 1 plus 0.025 over my n. Now this is compounded annually. That means once a year. So my n is 1. These 2 n's will match. So this is 1. times the time, and it says determine the amount of the account at the end of 7 years. So that's times 7. Now, me personally, I always teach, I can plug my calculator, I can plug this in just like it's seen, but some of you have older calculators, so you're going to want to do this. You're going to want to go ahead and do this part right here. And just go ahead and multiply that and say 7. Okay? Now, we're dealing with money, so I always say round to 2 decimal places, unless your directions tell you otherwise. All right, so I'm going to say 15,000, beginning parentheses, 1 plus 0.025 divided by 1, ending parentheses, raised to the 7th power. And I get $17,830.29. Again, money, always, it's understood that it's 2 cents, to 2 pennies. Unless it says otherwise. Compounded quarterly, it's the exact same formula, except your N changes. There are 4 quarters in a year, so N is 4. And yes, you have to remember that stuff for the test. I will not tell you. So everything stays the exact same, except where your N here was 1, it's now going to become 4. And here where it was 1, it's now becoming 4. Now here's what I do. I go ahead and tell, because some of you have older calculators, go ahead and multiply that out and use 28. If you have the newer ones like mine, you don't have to. So I'm going to bring this back up, and I'm going to change this 1 to a 4, and I'm going to change the 7 to 28. And I get this amount here, $17,858.96. So we get a little bit more money when it's compounded more times. Okay, and now we're going to go to monthly. It's the exact same formula, except for N is now 12. Again, it's the same amount here. Over, except for now my N's are going to become 12s. The time still stays. Again, 12 times 7, go ahead and multiply that out and get 84. You do not have to, because I'm going to show it to you without it this time. I'm going to bring this back up by hitting second enter. That way I only have to change this 4 to a 12. I'm going to have parentheses raised to the 12 times 7. Or you can put 84. It doesn't really matter. Okay, I don't like to hit many buttons, so I just say 84. So $17,865.45. Okay. Oops. Where am I getting that from? I just copied one up there. Let's try this again from what my calculator says. $865.44. I don't know why I was just copying that. You will notice that as N increased, so did the money, just a little bit, okay? But see what happened? There's more money that increased, like $28 here, but only $7 here, okay? What happens is at some point, if you had a supercomputer and you kept hitting enter and making this 12 bigger, what would happen is this would pretty much level off. Okay, if you made this 365 or some big number, you probably wouldn't even have any change in the pennies. So what happens is it ends up through calculus, you end up with this formula here. Now again, here it says compounded continuously. That's the word you want to look for. And then this would be our formula. So that's the one we're going to use this time. I'm going to bring it down here so you can see it. This is the formula. Okay, this everything we know, we just plug in. We know our principal is the 15,000. That's how much we're investing. E is just that constant, that 2.72, blah, blah, or 718, whatever it is. My rate is still 0.25, and my time is still 7. Okay. So we're just going to, again, for those of you that don't have the calculator, like mine, you might want to go ahead and multiply this out, but you don't have to if you have one like me. 15,000 E, I can find E, there we go, to the 0.025 times 7, and you get this number right here, okay? So you get about, and I always use this approximately, $17,868.69. See how if you'd have kept going bigger, you probably would get this same number and it would never really increase at all. Okay. All right. So that is that. I'm going to make a second video for this one here.